Hello, everyone. My name is Ethan Villalovoz, and I've had the opportunity this summer to participate within the Robotics Institute Summer Scholarship Program. Here, I've had the opportunity to be mentored by PhD candidate Michelle Zhao and two faculty advisors, Dr. Henny Almani and Dr. Reed Simmons. Within this presentation, I want to take the opportunity to show you what I've been doing these past 10 weeks, doing research within clarifying feature overspecification and reward learning from state corrections via follow-up questions. So to set up the scene for us, we've seen a lot of autonomous systems today affect us in different ways. From our personal lives and having a personal AI within our laptop, all the way to work, in which we see larger autonomous systems help us do manufacturing, such as building a car. For our case, in this research project, we'll be focusing on robots designed for assisting people in household tasks. And in this scenario, we can see that we're focusing in a robot helping a human put dishes away. So the biggest thing is the robot needs to know what people want. And this can be done through numerous ways. Specifically, as we can see from the image, the human telling the robot, this is how they want the dishes. For this work, we envision that an interaction can be done through correcting the state intermittently during the robot's task execution. So as we can see in the image on the left, the robot puts the red cup on the bottom portion of the rack. However, after the human corrects it to be on the top portion. Our goal is to have the robot update its model to align better with the user's preference. And this is ongoing as more objects are introduced into the environment. So because of the previous iteration, and now a purple bowl is introduced within the environment, the robot believes that it should go on the top rack, because the previous correction for the red cup went on the top rack. However, the human now puts it on the bottom rack. So as more objects are introduced continuously, we hope that we want to find that we can do this really well of updating the robot's beliefs to better align at the very end. Now, naturally, right, even though we can see that after state correction, this may be where the individual wants their object to be within the setting, naturally we ask why. Going back to the example of the robot putting the cup on the bottom of the dishwasher and the human correcting to the top, the robot may ask, did you do it because it was red? Should it be placed in the top rather than the bottom then? So state corrections do a very good job of creating these generalizations. However, let's say you had a scenario in which you have a special cup that you got from vacation that has all this nice artwork. And particularly, the reason why you put it on the top rack now is because the bottom rack is too hot and you're worried that it'll melt the paint on the cup away. So this is a very specific case, and we hope specifically by, having clarifying questions, this can actually update the robot's model and align with the user's preferences even better. So to drill this home, the research question we're trying to answer within this project is, can we enable robot learning from iterative state corrections and bootstrap learning via clarification questions? So two large contributions we hope from this work is to learn from corrections. As we've seen from previous works, a lot of works touch on physical human-robot interaction, which is, physically changing the action to the robot by actually, handling the robot physically. Now, rather in some other settings, such as maybe golf, as actually having hand on the individual to help improve their swing, that is great. But for our case, in a household task, this is not as human-like as we would want. Particularly, for example, if your friend is helping you unload the dishwasher or load it, you won't be grabbing their arm to, navigate them where you want the dish. It should just naturally see that from your state corrections or specifically picking up the cup and putting it elsewhere, that, from now on, you should put it there. So robot learning from state corrections to align with human preferences, we hope we can also enhance this performance. And then the second contribution we focus on is proactive dialogue. So clarification questions. we hope that from, having the robot prompt these questions during the user's guidance or corrections, that it will reduce its uncertainty and have better efficiency of knowing what the robot model should be and reduce errors for the human preference at hand. So the overall workflow we're trying to establish is the robot places an object within the environment, the human corrects it, and then from there, the learning begins. The robot updates its beliefs based on that single human correction. It will then prompt a question and gain that human response. And then from there, it should have greater certainty of what the reward model should be from the human response. And it'll continuously do that for all the objects that exist within the setting. So to set up an example of this, we have three states. We have S naught, which is essentially the initial state of the yellow cup. S1, which is the robot's placement of the yellow cup, S1. And then the human correction state, which is essentially taking where S1 was and putting it in the true reward state for the human preference. So from here, right, for a preset defined of reward models, the robot sets their belief to be uniform across all the models. However, specifically in this case, the true reward model for the user preference is reward model Ethan. And as we can see from this human correction, it does a good job of having some certainty. But as you can see, reward model Simmons is much higher. So this is where we come in specifically with the clarification question, and where the robot could possibly ask, for this given object, so it's a cup that's yellow in glass, which of the features, were relevant? So in this case, we color, type, or material. And based on this user input, it should help us better have a better understanding of, what the true user preference is. So in this case, for reward model Ethan, the reason why he moved it is because it was the color and the type. So it was because it was yellow and a cup. That's why he moved it elsewhere from the robot's placement. So from that, as we can see, type and color. Once we thereafter update its beliefs, we can see that Ethan's reward model is much higher now, and Simmons' reward model is much lower. So it's much more confident that the user preference is reward model Ethan, which is great. So what we need to do for future work is establish more of a continued clarification question implementation. As we saw, having clarification does a great job of providing more certainty for a robot and its beliefs. However, we saw that it was more of a naive approach of just asking for its features. We will want to be able to talk about more about the environment, but also possibly having the robot have more control rather than having it more be an open-ended question for the human. Thereafter, we would like to conduct pilot user studies so we can have a true sense of our implementation and our research is going in the correct direction of actually improving users' preferences based on the established idea of state corrections and proactive dialogue. So this is the end of my presentation. I do truly want to say thank you to the directors of the Robotics Institute Summer Scholars Program, Director Dr. John Dolan and Co-Director Rachel Burchin. None of this would have been possible if they had not given me this opportunity to come to Carnegie Mellon University and have this amazing experience. I also do want to thank the HARP Lab and the Razzle Lab for this opportunity, and Dr. Henny and Monty and Dr. Reed Simmons, respectively, to take me under and have the opportunity for this project. I would also like to sincerely thank PhD candidate Michelle Zhao for being an amazing graduate mentor, showing me a new side of robotics research within robot learning. And it has convinced me that I truly want to do this for my PhD next year after I graduate from my undergrad. I would also like to have a shout out to the other RIS intern within my lab, Annika. It's been such an amazing time and going through this whole learning process with her too. And it has been such a great time. Thank you for watching my presentation, and please feel free to reach out if you have any questions.